Good morning to all. Today I am going to start protein synthesis, okay, by using the solid phase synthesis. In previous class, we have discussed what are the amino acids and what are the types of polypeptide chains. Let's see the synthesis of peptide chains or solid phase synthesis. Okay, let's see this one. Solid phase method. So actually 4 steps are there during the peptide synthesis. 4 steps are there. Okay. So first we have to protect the amino group and the activation of acid group. So that is the second step. And what is the third step here? So next step is the formation of peptide bond, and the last step is the deep protection. Okay. Deep protection. Let's see the solid phase method. So what are the solid phase method? Okay. The inorganic chemistry, peptide synthesis, the products means peptides which are linked, which are organic compounds which is having multiple amino acids. Okay, so more than 2 amino acids will be there. So in polypeptide chain. Okay, so these are linked through the amide bond or peptide bond. Amide bond or peptide bond. The biological process of producing the biological process of producing long peptides long peptides is known as protein biosynthesis. What it is called? Protein biosynthesis. Protein biosynthesis. Okay. Protein biosynthesis. Good morning. Okay. So here we are. How we have to produce biological. This is the biological process of producing long peptides. Okay. Long peptides is known as protein biosynthesis. Okay. Protein biosynthesis. We can proceed this one through SPG, semi-permeable, semi-permanent protecting group. So first step is we have to protect the amino group in this. So we have to take this. First we have to do semi-permanent protecting. Okay. In first step, what we have to do first we have to protect the amino acids. Okay, amino group, because which is a very active group which is involved in during the peptide synthesis and disturb the formation of peptide synthesis. So thereby we have to protect the amino group first. Okay, so for that one we have to follow these 2 types of protecting groups. That is nothing but first one is SPG, semi-permanent protecting group is one of the method, and TPG. What is TPG? Temporary. Means temporary. Okay, temporary protecting group. Temporary protecting group. Okay, semi-permanent protecting group, or we have to use a temporary protecting group. Means appadikappudu protect chesi we have to deprotect after the formation of peptide. We have to deprotect this one. Okay, so here let's see what are the steps involved in this solid phase method one by one. Okay, first we have to protect. Here NH group is there, so we have to take this one. R1 is there. This is a COOH. So this amino group should be protected. This is a TPG, temporary protecting group. Okay. temporary protecting group, and this is linked with the SPG, semi permanent protecting group. Okay, so this one. Next. Okay, so by removing water molecule, and here we have to add the linker. We have to add the linker. Okay, so how we have to add the linker means, here we have to eliminate this H and this H, which is a hydrogen is present, which is in linker. So thereby it removes water molecule. So what we will get, NH is there, TPEG is there. Next, here R1 is there. Okay, which is attached to SBG1, and here double bond O is there, which is a link to linker NH. Okay, we have to write NH2 here. Okay, what is linker here? First, linker NH2. Linker is having, this is a resin, this is a linker. Okay, so in this one of the hydrogen which is present in the amino group and this hydroxyl group will be removed. Okay, will be removed. Thereby we have to remove the water molecule and form the. So what will be formed here? CO is there, and we are removing one of the hydrogen. Okay, one of the hydrogen. We have to remove the water molecule, and remaining NH will be there, which is attached to the linker. Okay. So next we have to remove the removal of temporary protecting group. Here we have to remove the temporary protecting group. Second step. This is the first step. Next one, what is the second one? Removal of the TPG. I want to write short form. TPG means temporary protecting group. This is the TPG. We have to remove this TPG. Okay, thereby what we will get here? Again we will get back the amino group. Okay, amino group. So thereby here R1 is there. Okay, next here SPG1 is there. Next here we are having double bond O, NH, which is attached to linker O. Okay, linker O. Next, we have to add another amino acid. Okay, we have to add another amino acid. This is the first step. This is the second step, and the next one is the third step. I am writing here. Okay, this is the third step. In third step, what we have to add here? We have to add one more amino acid. Okay, so here we have to add one more amino acid, and what will be happen? These amino acids are linked with each other and form the peptide bond. Okay, peptide chain ela form avutundi, okkoka amino acid manam join cheyali. Okay, so we have to join each and every amino acid, okay, to this one. Thereby it forms a peptide chain. So if more than 50 amino acids will be there now, so then it is called as protein. Okay. Okay, so next what we have to add? We have to add one more one. Third step, coupling of the next protection. Coupling of the next protected amino acid. Just I want to write a short form. AA means amino acid. So which amino acid we have to add? Here I will write here. Here TPG is there. Okay. So next here it is having COOH group. Here we are having another amino acid. Okay, which is a different one. Okay, so we are adding this amino acid to this chain. Okay, so let's see. Okay, so already you can write this one, TPC, NH is there. Next, R2, SPG2. I want to write here because మనం రాయాలి కాబట్టి ఇక్కడ రాస్తున్నా. Okay. Next, this is a one, and what we have to do? We have to remove water molecule from this amine group and this OH. Okay. So thereby what will be happen here? This NH. Here we are removing one of the hydrogen and this OH. Thereby we have to remove the water molecule. Okay. Write that one also. Water molecule. Okay. So next, what will be happen here? So this is means we have to join this amino acid to this one. Okay. So next, here R1 is there, SPG, one semi-permanent group protecting group is there. Next, here CO, NH, linker will be there up to end the reaction. So in last step we have to remove the linker after formation of protein. So this linker should be removed. Okay, should be removed. Next, so this is the third step. Next, repeat the protection, deprotection. Next, what we have to do? We have to remove this temporary protecting group. Okay, so we have to remove the second step, removal of the TPC. Removal of the TPC. So like that. What is the step? Next step, removal of TPC means repeat deprotection. First we have to protect and then next we have to deprotect. Okay, repeat deprotection. Step 2. Okay, and coupling step 3. Step 3 N cycles. Okay, ఇలా మీరు యాడ్ చేసుకుంటూ వెళ్ళారు అనుకోండి. We have to add one more. So like that we have to add totally this group. So I will write here NH2 is there, R N+2, Sp G N+2. Okay, so next we have to add the groups, means amino acids. We have to add number of amino acids. Okay, Rn, Sp, Gn, NH, R1, SPG1. Next, double bond NH, which is attached to linker. Okay, linker. Next, here how we will get? This is the polypeptide because here we are using number of N means number of amino acids. We are using number of amino acids, so that's why we have to remove this one. Okay. This groups, semi-permanent groups, we have to remove the semi-permanent groups. Okay, and we get back these R groups. Okay, thereby we can synthesize the polypeptide chains. Okay, so next step is last step. Next, I will write here. I don't have space, so that's why. This is the third step, right? This is the fourth step. Next one, fifth step. Okay, what is the fifth step here? I don't have space, so that's why just you have to note down. First step is, first we have to take a amino acid and we have to remove the water molecule from the linker. Okay, next we have to add the one more amino acid to this one. Okay, and we'll get this one. Okay, so next we have to add the amino acid. This will get the coupling of next protected amino acid. This is a next what is like that we have to join the n number of amino acids. Thereby we'll get the polypeptide chain. Okay, next what we have to do? We have to remove these semi-permanent protecting groups. Then we'll get the original protein or polypeptide. Okay, so what is the last step here? This is the 3, this is the 4, and fifth step is I'll continue from here. Okay, what is the this one? Otherwise, you can write like this also. దీన్ని అట్లా వేసుకోండి నేను రాస్తాను. This is the step kada. So next, fifth step. What is the fifth step? Cleavage and the protection of the this SPG1. Okay, semi-permanent group. I want to write semi-permanent group. Then we'll get back this one. Okay. Here NH2 is there. Okay. Rn plus 1. Okay, we'll write again. NH2 R N plus 2 double bond. Okay. NH RN double bond O. NH R1 double bond O NH2. This is our protein. Okay. Okay, and plus resin. And plus we have to remove the linker. We have to remove this linker. Okay. So next one. So we can write the cycle form. Okay. This is the we can write this one as a cycle form, short form. Let's see the cycle form of this peptide synthesis. Peptide synthesis. Okay. So first we have to take a resin. Okay. So next deprotection amino acid. First we have to do the deprotection. Okay. Deprotection. Next we have to add this resin to this one. Then what will be happen? Activation. Next for this we have to add the amino acid. Next this amino acid and this activated one get coupling. Okay. Coupling. Okay, so next one is again we have to go for this one. Again what it will give? Cleavage thereby we'll get the peptide. What is the last step? Peptide. Okay, peptide. So this is the cycle form of this. First we have to take the deprotected amino acid, which is the activation means here resin. We have to add the resin and thereby it gets activated. For this activated chain we have to add the amino acids one by one. So thereby coupling reaction will be there. So here we can add some more. So more in this step coupling means here more amino acids we have to add the more amino acids. Okay. So next what is the step? Last step, cleavage is the last step. Okay. So this is about the synthesis of amino acids. Okay. Right now. So next one, next topic, proteins, biological importance of proteins and classification. Classification. Classification of proteins. Classification. Here. So protein is a polymer of amino acids. Means more number of amino acids are what happened? These are combined and form a polypeptide chain. Okay, if more than 50 amino acids is present in that polypeptide chain, then it is called as proteins. Okay, these proteins are a polypeptide groups alternate. And means here specific amino acid groups will be there for a particular polypeptide chain. Okay, for a particular polypeptide chain. So these groups are linear polypeptides or some other. Means here, so folded each shape interferes the several standard elementary three-dimensional structure. These are arranging in 3D, three-dimensional way. Okay, three-dimensional way. And here, based on this, proteins are classified into two types. Proteins are classified into two types. Okay, one is monomeric proteins, monomeric proteins. Okay, and second one is oligomeric proteins, oligomeric proteins. Here, mono means what? One, single. Is it or not? Mono means single. Okay, single chain will be there. They are having single polypeptide chain. Okay, mono means single, right? Mono means single. So here single polypeptide chain will be there. Single polypeptide. If single polypeptide chain is present, so then it is called as monomeric proteins. Monomeric proteins. If more than two, okay. So more than they are having here. Oligomeric means what? More than they are having. They are having more than two polypeptide chains. Two polypeptide chains. So this is called as oligomeric proteins. This is called as oligomeric proteins. What is the oligomeric proteins here? Monomer means single polypeptide chain is present in this one. And what about these oligomeric proteins? They are having more than two polypeptide chains. Then it is called as oligomeric proteins. Okay, on the basis of polypeptide chains, proteins are classified into, means these polypeptide chains, proteins are classified into four types. What are the proteins are classified into? Four types. Chains, based on chains. Okay? Four types. One is primary structure. Second one is secondary structure. Secondary structure. In this, again, it is classified into alpha and beta pleated sheets. Okay, in secondary structure, again is classified into alpha and beta pleated sheets. Okay. So here, two will be there: alpha helix, beta pleated sheets. Pleated sheets. Okay. So next one, third one. What is the third one? Here, tertiary structure. Tertiary structure. Tertiary structure. Okay. So here, four types: primary structure, secondary structure, which is classified into again two types, which are alpha helix and beta pleated sheets. And what about the third one? Tertiary structure. Okay. Tertiary structure. Let's see one by one. What is this? Primary structure. What is the secondary structure? Let's see the primary structure. Okay. Primary structure. The number and sequence of linear. Here how these are numbered and sequence of amino acids. Okay. Sequence of amino acids. How these are amino acids in polypeptide chain constitute primary structure. They are linear. They are linear. What is this? Linear chain will be there in primary structure. Linear. This is having a linear. Means the amino acids are arranged in a linear mode. Okay. And having linear and having specific sequence, amino acid sequence, specific amino acid sequence. Okay, specific amino acid sequence. Okay, ma'am. So this is what is this one? Primary structure. Mainly it consists of a linear chain, and is having specific amino acid sequence. So then it is called as primary structure of the protein. Okay, primary structure of the protein. The sequence of amino acids are arranged in the basis of DNA. Okay, how it will arranged? It will be arranged the sequence. Next point, the sequence of amino acid. I want to write AA, which is called as amino acid. I want to write the short form. Okay. So amino acid are arranged on the basis of DNA. The cell give information to the protein. So the cell gives the information to the protein. First, amino acid sequence done by the DNA. Okay, first it will transfer to this one. Okay, so how it will be there here? NH2 plus. Next, we have to add the amino acids. Like this. Another end carboxyl group is there, and another end NH2 group will be there. So this is called as N terminus, and this is called as C terminus. Okay, this is N terminus and this is C terminus. Okay, so this is about the primary structure. Only one chain will be there, means linear structure will be there. Okay. So these are nothing but amino acids. So whatever the amino acids I have given you now. So there are specific amino acids will be there for particular proteins or polypeptide chains. Okay, but here we are not mentioning the which amino acid it is. So there just I am explaining the what is the primary structure, how it will be present. Okay, so this is the linear chain which is having amino acids, specific amino acids. Okay, so and it is having NH2 group, and as well if you take any polypeptide or protein, so it contains amino group as well as a carboxylic group. Okay, another end. So first this is the N terminus and that is the C terminus. Terminus means ending. Okay. So next one is, this is the primary structure. Let's go for secondary structure. Primary means you have to remember this is a linear and having specific amino acid sequence. First, so what it will give, the sequence of amino acids arranged on the basis of DNA. So immediately the cell give information to the proteins. Okay. So this is about the primary structure of the proteins. Then let's see the secondary structure. Secondary structure. What is the structure? Most of the long polypeptide chains are folded or coiled on the number of bases. They are called alpha helix. Most of the long pair polypeptide chains, long PP polypeptide means PP chains are folded or coiled based on this number of ways. They are nothing but alpha helix, beta pleated sheet, and another one is also there, triple helix. Three types are there: alpha helix, beta pleated sheet, and triple helix. Okay, let's see what is alpha helix. In this alpha helix, 3.6 amino acid residues will be there. In the alpha helix, 3 amino acid residues are present for complete form. So the central axis of 1.5. I will show you how it is present. So this is the one. So here this is the C terminus. And this is a N terminus. Okay, this is N terminus. This is N terminus. So here, how many amino acids per turn? It is having 3.6 amino acids. 3.6 amino acids. And what is the distance between this turn? Means 1.5 angstrom units. For each turn, there will be 3.6 amino acids will be there. Okay, for each turn. So means it contains 3.6 amino acids. Okay, and what is the distance between these two turnings? What is the space? What is the distance? It is about 1.5 angstrom units. 1.5 angstrom units. So this is about the alpha helix. Okay, alpha helix. So like this, it will be there, alpha helix. Let's see the beta pleated sheet. How the amino acids are arranged in the beta pleated sheets. Okay. This is the alpha helix. Okay, alpha helix గుర్తు పెట్టుకోండి. జస్ట్ మీరు ఇలా ఇలా వేసి ఇక్కడ రాసినా ఓకే సరిపోతుంది. ఓకే, నెక్స్ట్ beta pleated sheet. Beta pleated sheet. Beta pleated sheet. In this form, the molecule is almost completely extended and hydrogen bond forms. Means here, if you take DNA, so in DNA, one chain is linked through the another chain through the hydrogen bonds. Already we have seen. So that means pyrimidines are form the hydrogen bond and with the purines. Okay. So here also, what will be there in this form? Molecule is almost extended. Okay, almost completely extended and hydrogen bonds form between peptide groups of polypeptide segments. Okay, polypeptide segments. I will show you how this is present. Okay, so we have to write. This is a one. Some R group will be there. Just I am mentioning the peptide bond between this one. Okay, just I am writing R2 is there. Okay, so next NH will be there. CO. Okay, like that. Okay, we can write like that. Okay, so this is this one. Okay, this is the CO group or NH group, whatever it may be. Okay, so next this is so like that. So if you see here, there is a hydrogen bonding present between this hydrogen and this carboxylic group. Okay, you can see that clearly. So this is the hydrogen bonding present between this carboxylate, means this C bond and H, C bond and H, C bond and H. Okay, so this is the beta pleated sheet. Okay, there is a hydrogen bonding present between the two polypeptide chains. Okay, so clearly it will show like this. I will show you. Group or will be there. Okay, means here hydrogen bonding is present. So this is the beta pleated structure. Beta pleated structure. Beta pleated structure. Okay. So next one, triple helix. Okay, so this is first in alpha only one chain will be there. In this two chains will be there. Let's see the what is the tertiary triple helix. Okay, triple helix will be there. Okay, in this secondary structure is divided into three types, which are alpha, and this is the beta plated sheet. Okay, so next one is triple helix. Triple helix. Triple helix. In these two segments, if two segments are, segments means which are chains, okay, chains which are combined, means are aligned in the form of two C terminus direction, N terminus to C terminus direction, C terminus direction, okay, or in the vice versa, C terminus is connected to N terminus chain. Okay. Next, what is the if one segment is aligned in the N terminus to C terminus, okay, terminus direction, or other C terminus to N terminus, the beta Pleiades structure is called as anti-parallel. I will show you how it is actually. So this is a C terminus. It is started with C and this is the end. Next, another chains will be there. So this is with N, C, okay. So another chain will be there. Here also, this is N to C terminus. This is a triple helix. Alignment of chains. In which direction? Direction is important in this one. Okay. So this is about the triple helix. Let's see the tertiary structure. This is a collagen. Actually, collagen will be there now in our skin. Okay. So made up of collagen protein. Okay, collagen protein. So it means decide the our. Okay. So this is the triple helix structure. Let's see the tertiary structure. Tertiary structure. Tertiary structure. The polypeptide chain, PP chain, may undergo coiling or folding. Undergo coiling or folding. Coiling or folding. Okay, to produce the tertiary structure. We can write it like this or tertiary structure. Tertiary structure. Okay. So it has a fold important property of the shape. The way the structures folds will be there. Okay. So here I will write this tertiary structure. which is attached to another one. Okay. So here C double bond O minus will be there. This is attached to this one. This is a chain. This is a chain which are having amino acids. Means this is attached to this one. Okay. So like this, we have to write CH3 here. Here there are some types of bonds will be there. This is A bond, B. Okay. Next here also which type of bond is present? Hydrogen bond is present. Okay. B. Here also hydrogen bond is present. Actually COO is there, but we have to write the COO minus. Here ionic bond will be there. NH3 plus this is the minus. Okay. Minus. Okay. So this is a C type. Here this is a D. Okay. E, C. This is also C. Okay. So what is here? A is a disulfide because here there is a bond present between sulfur to sulfur. So that's why it is called as disulfide bond. Disulfide bond. B is hydrogen bond. Hydrogen bonding is there. Okay. B types are hydrogen bonding. Okay. C is ionic bond because plus minus there is interactions between this ammonium and this carboxylate ion. So plus and minus. So that's why it is a ionic bond. Ionic bond. Here these two are similar groups which are having hydrophobic interactions. D is a hydrophobic. These are not polar, non-polar interactions. So non-polar is nothing but hydrophobic interactions. Hydrophobic interactions. Okay. Hydrophobic interactions are there. And this is also D type. Means hydrophobic interactions are present in this one. Okay. So like this here, this is the protein chain which is having different amino acids. So between these amino acids there is a interactions present. Okay, interactions present. So these interactions it can be folded. So it is having interactions and it is in the folded mode. So that's why it is called as tertiary structure. Tertiary structure. So which type of interactions are there? Disulfide interactions are there, hydrogen bonding is there, hydrophobic interactions are there, as well as ionic interactions will be there. Okay, so this is about the classification tertiary structure. Okay, tertiary structure. So next one. So in next class I will explain about the biological importance of proteins and I will start the otherwise I want to complete this one. How much is that? So much. Okay, let's finish this chapter. Okay. So this is about the photota classification: primary, secondary. There are three types: alpha helix, beta plated strip, triple helix, and fourth one is a tertiary structure. Okay. So next one, biological importance of proteins. Biological importance of proteins. Proteins. Okay. So proteins consist a large part of amino acids, structure of cells, and are present in the tissues. Okay. So proteins are, so these are in so if you take any protein food, or it means our body is made up of proteins only. Okay. So this is present in number of cells, structure of cells, large part of structures of the structures of cells and are present in cell or tissues. Okay, so these are having special physiological functions. These are having physiological functions. First one is membrane proteins. Okay, so these are proteins and lipids from the major structural components of cell membranes. Okay, lipids and proteins. These are the major structural components. Mean cell is made up of lipids and proteins. Most of the cell consists of lipids and proteins. Okay, major structural components are nothing but lipids and proteins. Okay, so what are the major structural components of this cell? Is nothing but here lipids and proteins. Lipids and proteins are integral part or peripheral part. So many enzymes and coenzymes. Enzymes are associated with this cell membrane. Is it or not? Okay. So next, hormones. You know very well, hormones play very important role. Several hormones are peptides and proteins only. Several hormones are peptides and proteins only. Okay, peptides and proteins only. Okay, peptides and proteins, they play important role in the regulation of metabolic process. If you take any metabolic process, so that is controlled by the hormones. Okay, so maybe you listen about the hormonal imbalance is there, means so this is the deformation of the proteins. So if it is fails to produce the hormones in irregular, so there will be, what will be there, so hormone imbalance will be there. So we have to means correct that hormone balance by taking the proper food. Okay, so hormones will be there. So these are I will give some list of this one. Hormones. Pituitary hormone. This is alimentary canal hormone. Okay, so next one, somatotropin. This is growth hormone. What it is? Growth hormone, which is present in gastric. Next, TSHC means thyroid. This is very important one. thyroid stimulating hormone. Stimulating hormone. You have already, I thought I have already known about what is the hypothyroidism, what is the hyperthyroidism. So because of the hormonal imbalance, means the thyroid gland, okay, thyroid gland. So this hormonal imbalance will be there, thereby it produces two types of thyroids, okay. Cholecytokinin, cholecytokinin. This is the protein which is present in this one, okay. Next, FSHC. So this is nothing but follicin stimulating hormone. This is the secretin. Secretin. Okay, oxytocin. Oxytocin. During the childbirth, okay, pains will be there now. So it produces, means when it produces oxytocin, this is responsible for the labor change of women. Okay, so means during childbirth, so labor pains will be come now. So how it will come? Because of the production of oxytocin hormone. Okay, this is contained the renin enzyme. Okay, these are the enzymes and these are the hormones. So for the production of hormones, these are the responsible for this one. Okay, so this is about the hormones. Let's see the blood proteins. Blood proteins. Blood proteins. Blood proteins include the plasma proteins and plasma proteins as well as hemoglobin. Okay, hemoglobin. These are the blood proteins, you know very well. What are the proteins? Plasma proteins and hemoglobin proteins. So actually plasma proteins are albumin and chymotrypsin. Chymotrypsin. Okay, chymotrypsin. And blood protein is which is conjugated in globin and heme. Actually, you know well what is blood protein. This is the conjugated protein. Conjugated protein. This consists of protein. It consists of what? It consists globin part and heme part. Globin plus heme, which is called as hemoglobin, and this is a protein. And this is a protein. It consists of 4 polypeptide chains which are 2 alpha chains and 2 beta chains. 2 alpha chains and 2 beta chains. Okay, these are the 2 alpha chains and 2 beta chains. Each chain is attached to 1 atom of iron. Means here these 2 chains are attached to 1 iron atom. Okay, iron atom. Actually, I have explained you in the bioinorganic chemistry in your second semester. Okay, I hope you understand. So what is that? This globin and heme will be there. So these are attached to this protein globin chain, and heme is there. These are 2 proteins which are attached to, means these are coordinated with iron atom. Iron atom. Okay. Next, nuclear proteins. Antibiotics are there. So we are using antibiotics. Antibiotics. Our body itself produces some antibiotics which are nothing but proteins only. Proteins only. Okay. And nuclear proteins will be there. Nuclear proteins will be there. Okay. So in these are conjugated proteins. Nucleic acids. You know very well now. So nucleic acids, here proteins and combination of proteins and nucleic acids. Na means nucleic acids, whether DNA or RNA. So then it is called as nuclear proteins. Okay. So next, proteins. These proteins are include histamines, uh, histones, protamines, non-histone, chromosomal proteins, chromosomal proteins and all. Okay, chromosomal proteins and all. Next, I have explained you about already collagen. Collagen is a, so this is a fibrous protein found in many connective tissues. Means here, okay, this is a consists of a 3 helically chain. Means I have explained you triple helix. That is the collagen. So collagen is a found in many tissues. Okay, many tissues. So these are the importance of proteins. Okay, these are the importance of proteins. Okay, so the protein part will be over. Okay, we have completed the protein part. In next class, I will start the enzymes part. Okay, thank you. I will intimate you when will be the class because it is already late.